Okay. Hello, good morning, and good evening. Welcome to the first live edition of Math Agility Live. This is our new platform where students can send in their math homework problems to our social media channels, and we will answer them via Facebook Live every Tuesday and Thursday from 6 p.m. to 8 p.m. That's Pacific Standard Time, and it's Wednesday and Friday, 9 a.m. to 11 a.m. Manila Time. Those students who send in their questions from last Monday to Wednesday, again, that's PST or the Pacific Standard Time, and Tuesday and Thursday, Manila Time, we will be answering them, all those of questions today. So for our first math problem, this is from Kendra. She's from New York and she's in grade 7. Let me share you my screen. Okay, hope you can see my screen now. So this is the question from Kendra. Let's make it a little bit bigger. So it's actually an equation, and he tries to solve the variable x in question number 1. So that's x plus 7 equals 18. So how do we solve this? So let's again try to write the equation here. So x plus 7 equals 18. So the variable is, of course, x. This is our variable. And 7 are called constant. And also 18 is also called a constant. So now, there's a rule in our equation that all variables should be on the left side. So let's write a table here. So variables should be on the left side of the equation. So this is the equal sign that tells us this is an equation, and then all the constants should be on the right side of the equation. Okay, so if you notice, 7 is not in its correct position because we're saying constant should be on the right side of the equation. So how do we move 7 to the right side of the equation? So again, there are rules for moving constants or variables to the left or to the right of the equation. So if we move a positive number, to the right side of the equation, then it becomes negative. And then if it's positive, when we move it, positive, if we move it to the right side of the equation, it becomes negative. So if we say 7 is not in its correct position in the equation, and we move a positive number to the right-hand side of the equation, then positive 7 would become negative. So let's again write it here. So x plus 7 equals 18. So let's move 7. So x would now be equal to 18 minus 7, because 7 is actually a positive number. When we move it here, that becomes negative, right? So what is now our answer here? So since we already moved the number or the constant to the right-hand side of the equation, now we can solve it. So 18 minus 7 is 11. So that's the answer for question number 1. Actually, each student can send in their problem like for a maximum of 2. Sorry. So let's do the second problem from Kendra. So the next question is, so let's go back here. Okay, let's try to solve number 3. Okay, this one here. So it says 83 minus equals y minus 17. Okay, so let's try to scroll down here. So number 3, so 83 equals y minus 17. So again, our rule is the variables on the right-hand side of the equation and all constants, constant to the right-hand side, variable to the left-hand side of the equation. So two elements are not in its correct position. So y should be, the variable y should be on the left side and 83 should be on the right side. So since y is a positive variable, then if we move it to the left-hand side of the equation, that becomes negative, right? Correct. So negative y equals, let's copy again, negative 17. And then we try to move 83 to the right-hand side of the equation. Since it's a positive number, then that would become a negative number because we're moving it to the right-hand side of the equation. So negative minus 83. So what would be the answer? So let's copy again, negative y equals, adding this together would give us 100, negative 100, right? Now, we still have a negative in front of our variable y. So we need to eliminate the negative number here. So just divide both sides of the equation by negative 1. And then we get y equals 100. So that is our answer for question number 3. Okay. If you have, if you don't understand some of the process I've shown you here, you can type in the comment section and let me know, and I'll answer back later. Okay. So let's go to problem number 2. Okay. This question is from Stephanie. She's doing, probably this is part of her physics class, and she's grade 12 from San Francisco. So this is the question. So in the circuit below, V1 is 4 volts, V3 is 3 volts, and then we're trying to find V2. So there's also a hint, says, hint, the voltage on the wire at the top is 10 volts higher than the voltage on the wire at the very bottom. So it's actually referring to this voltage here. Sorry. So to this 10 volts here. So this is positive on top and negative at the bottom. So how do we solve this? Actually, there's a Kirkshop's voltage law that says if we add together all the voltages in a loop or in a circuit, it will be equivalent to 0. So let's try to do it. So we'll start our loop from the negative side of this voltage source. So let me just so it will be on this direction. Let's do it clockwise, okay? So let's start. So negative 10 plus V1, right? Plus V2 plus V3. Then the total sum of all the voltages would be equal to 0. And since V1 is equal to 4 volts, so let's try to substitute all the values in the given equation. So negative 10, so B1 is, hold on, B1 is 4 volts. So this would be 4 plus 4. And then V2 is, V3 is 3 volts. So we're actually looking for V2. So V3 is 3 volts equals to 0. Right? Okay, so now we can add, again, similar to the first topic that we had, all variables to the left, all constants to the right. Okay, so we will combine first like terms. So these are like terms here. So negative 10 plus 4 plus 3. So it's equivalent actually to negative 10 plus 7, right? Negative 10, combining these two would be plus 7, and then plus B2 equals 0. So negative 10 plus 7 is negative 3, and then plus B2 equals 0. So since negative 3 is our constants, we need to move it to the right-hand side of the equation. And since it's a negative, it will become positive when we move it to the right-hand side. So V2 will be left on the left-hand side of the equation. So V2 equals 3. And our unit should be in volts, or V. So this is the answer for question sent in by Stephanie from San Francisco, and she's in grade 12. Okay. All right. Let's do number 3. Okay. Let me just make it a little bit smaller. Okay, so this is a statistics problem, and this question was sent by Fernando, and she's already in college, and he's in college, and he is from San Mateo. This is actually around the Bay Area here in San Francisco. Okay, so let's try to read the problem. Let x, okay, so it means x. Let x represents the full height of a certain species of tree. Assume that x has a normal probability distribution with a mean of 320 feet and a standard deviation of 45 feet. So find the probability that the height of randomly selected tree is between 190 feet and 455 feet. So actually there is already an answer. So the probability of x between 190 and 455, I think I already wrote it here, is 0.997. But I'll show you the solution. So enter your answer as a number carried to it. I think this is taken from some of the learning platforms or the e-platforms of this student. So let's try to answer this question. So let's write what are given in the problem. So given that it's a normal probability, of course. So it's a normal probability or a normal distribution. So that would give us, and then there's a mean of 320 feet. So the symbol for mean is actually your mu, and that is 320 feet. And then the standard deviation, or the SD, standard deviation, is what? 45 feet. So that is sigma 45 feet. All right. So what else? So we're trying to find the probability when our sample is from 190 feet to 455 feet. So it means our x, or a random variable, would be from 190 feet and from 455 feet. What's the probability of getting this sample that has this tree height between these values of 190 and 455? So since we have the mean value of 320 feet and then the standard deviation of 45 feet, we can actually use what? The z-score. We can translate everything into the z-score graph. Okay. So so the formula for z should be your x, right, minus mu all over sigma. Okay. And then, so we need to substitute this value. So we have actually two x's here. X1 would be your 190. So X1 is 190 and X2 is 455. So we can solve two values for Z, right? So let's try to solve the first value of the Z score. So Z sub 1 is equal to X sub 1 and then the mu given and divided by the delta. So 190 minus mu, which is it 320? Yes, 320 divided by 45. So the answer here is what? So 190, that's actually negative 2.89. Okay, so now let's do, okay, let's see if there some questions here from our audience. You can ask questions or you can raise. Okay. Okay, let's again do for Z sub 2. So X sub 2 minus mu over sigma. So X sub 2 is 455 minus 320 divided by 45. That is equivalent to 3. Okay. So this one is actually negative. Let me just clear it. So negative 2.89. And the other one is 3. So now we have the Z values. We can now graph it. Z score graph. So let's say this is our Z axis, the Z value. And then since it's a normal probability, so we have the bell-shaped. And the middle of this would be Z equals 0, right? So our Z sub 1 is a 3. Let's say it's around here. Say sub 2. Okay. Our Z sub 1. And then our Z sub 1 is a negative 2.89. So let's say it's around here. So Z sub 1 is negative 2.89. So the probability is actually equivalent to the area covered by these two limits or these two boundaries. So our boundaries is from negative 2.89 to 3. So we can say from here up to here. So all this area covered by in the middle with this portion would be your probability. And how we can compute it. So actually we have two ways to do it. One is we can use technology and the other one is we can use the Z-score or the table. So oops. So P1. So if we try, since if you look at the table, it's a cumulative value. So meaning from here, we will get a value up to here for Z2. All the areas starting from here would be up to this end. And then the second value, which is Z1, would be all the values from here up to this value here. And then the blue one would be up to this value here. Okay. So if you look at the table, we can see that the cumulative value for the blue part or for Z sub 2 is Z sub 2 is 0.0 9987 in 4 decimals. And then the red part, which is the one from z sub 1 to negative, the z sub 1, which is negative 2.89, is 0.0019. So to be able to solve the area in the middle, the blue part, we need to get the difference of these two areas, right? So probability of 190 between x, z, 445 feet would be this value here, which is 0.9987 minus 0.0019. So if you try to get the difference of these two, we have 0.9968, or in 3 decimal places, because that's the requirement, so we have to put it in 3 decimal places, so 0.997. So that's our answer for this question. Okay. Right. So let's move to question number 4. So question number 4 is from Kyla, and she's in college and she lives in San Jose. Okay, so hope you can read the question. So, but I will also be reading it as well. So let's try if we can make it a little bit bigger. So use the given graph of f to find a number delta such that if absolute value of x minus 3 is in between 0 and delta, then the absolute value of the f of x minus 2 should be less than 0.5. So this is actually definition, the precise definition of a limit. Okay, so let's try to write. So the what does this say? Okay, let me just pull out the exact definition and I'll show it to you here. Okay, so let me just okay here. So let me just unshare first my virtual board and so you can read this. And then let me show you my screen. Okay. So this is the precise definition of the limit. So let f of x be defined on an open interval about c, and except possibly at c itself. We say that the limit of f of x as x approaches c is the number L, and we write the limit of f of x as x approaches c equals L. So I'll be writing it here. So the limit of f of x is equal to L as x approaches c. And if for every number epsilon greater than 0, there exists a corresponding number delta greater than 0, such that for all, so x, absolute value of x minus c greater than in between 0 and delta, there is also this value for epsilon, which is the absolute value of f of x minus L, which is less than delta. Sorry, epsilon. Less than epsilon. So let's go back to the problem. So what is our L? We will try to identify what is the f of x, what is L, what is the epsilon, what is C, and what is delta in the given problem. Okay, so let me stop sharing this and then I'll share you again my. Okay, so I hope you can see my whiteboard. All right, so if we go back to the question, so what we're trying to do is find the number delta, right? So um, since from this drawing, 3 is actually our C, right? So this is C. C, oops, C is equal to 3. And then, so this is that one here in the middle. And 3.8 will be C plus delta. And then 2.6 will be C minus delta. And then 2 would be your epsilon, right? So epsilon, is it 2? Sorry, epsilon is 0.5. So 2 is actually your uh, the middle term. So 2, this is your L. So this would be L plus epsilon and then L minus epsilon. So our L is actually R2. Okay, so let's move it here. L equals 2. Okay, so if we look at the difference between the 3 and 3.8, how much is it? So let's say 3.8 minus 3, of course, would be 0.8. And then the difference between 3 and 2.6, so 3 minus 2.6, that is 0.4. So which one is nearer? So if we look at this one would be nearer to our value C, which is the one that we are approaching to, right? Okay, so our delta would actually be, sorry. So since this is a smaller value, then our delta would be equal to 0.4, right? Based on this graph. So this is actually delta equals 0.4 because this value from here is nearer to 3, which is our C. Okay. All right. So I hope that is a helpful explanation. So we just need to find from our value C, which is 3, which value from both sides of the number C plus delta, which is this part here, which is the upper boundary of C, and C minus delta. And then whatever is the nearest to C, then that will be the value of 0.4, which is this one, right? Which we find out when we subtract 3 minus 2.6. Okay, so let's move to the next question. So it's the next question. So next question is from question number 5 is from Amy, and she's in grade 12 and she lives in San Francisco. So this is the question. Let's try to move it a little bit here. So Okay, someone wants to join. Okay, but he's out. He's gone. Okay. All right, so find the number a such that the limit exists. So the limit of um 3x squared plus ax plus a plus 9 over x squared plus x minus 2 as x approaches negative 2. And then we're trying to find the value of a from this limit. How so the first thing we need to do is that to be able to solve a, we need to see that if we divide these rational fractions, the polynomials, we should get an its remainder to equate to 0 by remainder theorem. So let's try to solve this by dividing the polynomials first and then try to find the remainder of this rational fraction. Okay. So let's divide. So 3x squared plus ax plus a plus 9 divide by x squared plus x minus 2. Okay. So let's try first dividing 3x squared by x squared. So we will get 3x, right? So 3x times x squared would be 3x squared. And then 3x times x would be is it x? Oh, sorry. There's no x plus 2 here. It's just plus 2, not. So this is plus 2. What am I trying to solve here? Okay, just the x plus 2, sorry. Because this is actually factorable to, so 3x squared plus ax plus a plus, divide by x squared plus x minus 2. Since if we try to substitute negative 2, this denominator would be equal to 0. So let's try to get the factor of the denominator, which is equivalent to x plus 2, right? And x minus 1. So since we're looking for a remainder that is equivalent to 0, let's try to divide x plus 2. So this is x plus 2 by the whole polynomial in the denominator. So we have 3x squared times x, which is this part here, and then 3x times 2 would be 6x. And then let's try to subtract this. So this will be 0. And then 6x. So ax minus 6x, right? So ax minus 6x. And then we have the constant a plus 9. Okay. So let's try to divide ax minus 6x by so that's a minus 6. So we can actually a minus 6, right? Divide by x. So x, let's try to write here everything. So I factored out x. So x quantity a minus 6 divided by x will get a minus 6. So again, multiplying back here, we will get x and a minus 6. And then the 2 will be plus 2 a minus 6. Okay, let's try to erase this so it's not confusing. Okay, so let's try to subtract. So this would become 0. So this is a plus 9 minus 2a minus quantity minus 2a minus 12, right? So the total would be total would be negative a plus 21, right? So I'm just combining these two here. So our remainder would be negative a plus 21 over x plus 2, which is our divisor, right? And remain, so if we will write everything, so that would be x plus 2 multiplied by 3x plus a minus 6 plus this value here, negative a plus 1, which is our remainder, right? So by remainder theorem, this should, to make it a perfect or a divisible by the factor x plus 2, which we wanted to know. So we will equate this to 0. So negative a plus 21 over x plus 2 equals 0. So uh, if we will try to multiply both sides of the equation by x plus 2, this cancel out and this will be 0. So what is left is negative a plus 21 equals 0. Therefore, a should be equal to 21, right? So let's try to substitute this in the original equation. So the limit of 3x squared plus ax plus a plus 9 all over x squared plus x minus 2, x approaches to negative 2. We can now let's try to substitute this value. So limit, so limit of let's just reboot this. Just give me a second. Okay, limit, of x approaches negative 2 would be 3x squared plus 21x plus 21 plus 9. And then we can actually get the, what do you call this? The factor of x squared plus x would be, since we already factored it out, so x plus 2 over x minus 2. And then 3x squared plus 21x plus 30 over x plus 2 quantity x minus 2, right? So and then let's combine, let's factor out the numerator. So the factor will be 3x plus 15 and x plus 2, right? And then x plus 2 over x minus 2. So there is a hole in the graph, so we can cancel this out. So the whole is actually an x negative 2. And so the limit is now 3x plus 15 over x minus 2. So let's try to replace x as x approaches to negative 2. So 3 times negative 2 plus 15 over negative 2 minus 2. So what do we have here? Negative 6 plus 15 over negative 4. So that is actually 9 over negative 4. So our final answer, the limit of that is negative 9 over 4. Right? Okay, so let's move to the next question. Okay, uh, let me just go back to the main. Okay, so let's move to the next problem, which is number 6. So this question is, let's see. So problem number 6 is actually from William. He's in grade 12 and he's actually from the Philippines, from Mindoro, but he didn't say any which school. So the question is, okay, let me just make this a little bit bigger. His question is, find the limit of 1 minus 1 over x raised to the x as x approaches to infinity. So let's try to put, so this is a limit question and that's part of calculus. So let's try to put it in symbols. So limit of 1 minus 1 over x raised to the x. And then as x approaches to infinity. Okay, so let's try to substitute infinity, what we will get from here. So 1 over minus infinity to the infinity. So 1 over infinity is actually 0. So 1 minus 0 raised to the infinity give us 1 to the infinity. And this is actually an indeterminate form. Right? So to be able to so it's number 6, to be able to find a way, so we will manipulate actually the equation or the f of x to something that will not give us an indeterminate form 1 to the infinity. So let's use the exponential and the natural log function. So I would do is, so limit as x approaches infinity, let's take the exponential function of the natural log of 1 minus 1 over x to the x. So that means actually exponential function and ln when taken together would actually cancel out its effect, right? So it's essentially, it is still our f of x. So our f of x is 1 minus 1 over x raised to the x, right? So it's still the same. Okay, so how can manipulate this? So we can take out x in front of ln. So exponential function of x ln of the function 1 to the x raised. So that exponent we already put in front of ln, And then what else we can do here? So we can take the limit of so limit of x approaches infinity. So we can take out exponential function outside the limit. So let's say exponent, then the limit. So it's a property of limit x approaches infinity, and then x times ln of 1 over 1 over x, right? So we can actually let y equal to this value for limit. Okay, so this whole thing here can be equate to y, right? So essentially we have exp y. So let's try to separate y. So y would be equal to the limit of this value here, 1 over 1 over x, as x approaches infinity. And as a property of a limit, we can take x and our f of x separately, right? So we can distribute our limit. So limit of x as x approaches infinity multiplied by the limit of ln of 1 minus 1 over x as x approaches infinity. So now we have two limits. So it's a product of two limits. So let's take the value of the limit of x. So this will give us infinity, right? And if we take the limit of the value of ln of 1 over x, so ln 1 over 1 over infinity. So again, 1 over infinity is equal to 0. So this would give us 0. And ln of 1 is actually equal to 0, right? So y equals infinity times 0. And again, this is an indeterminate form, right? So indeterminate form. So if there's a rule that if we get an indeterminate form of a limit, we can use the Lopital's rule. Okay, so Lopital's rule. So limit of what's that? X times ln of 1 minus 1 over x as x approaches infinity. Since you get this indeterminate form, we can manipulate again this equation to make sure that we will not get another indeterminate form when we get the limit of this function. Okay, so the way we can do this is we can separate x and ln of 1 over x by doing a fraction, and this is how you can do it. So limit of x approaches infinity. So let's take ln as our numerator, and to bring x to the denominator, we should put 1 over x, right? So again, let's take the limit of this. So ln of 1 minus 1 over infinity over 1 over infinity. So this would give us 1 over infinity is 0. And ln of 1 is also 0. So again, this is an indeterminate form. So if we're doing the process of L'Hopital's rule, we just continue doing the differentiation method for the numerator and the denominator separately, right? That's the rule of L'Hopital's rule. So let's take again the derivative of our numerator. Okay, so ln of 1 over 1 minus x should be 1 over 1 over x, and then the derivative of 1 over x is x squared, right? Which is negative, and that becomes positive. Okay, for the denominator, the derivative of 1 over x is negative 1 over x squared, right? Okay, so if we try to simplify this, x squared cancels out, right? And we have the limit of 1 over 1 over x as x approaches infinity. Okay, let's see. If we substitute infinity here, what value will be getting? So limit of 1 over 1 minus 1 over infinity. So again, 1 over infinity is 0. So this is 0. So our answer should be, hold on, there's a negative here, right? Yeah, there's a negative, sorry. Because of this negative here. So negative, negative. Or we can take, okay, let's see, a limit of infinity, or we can manipulate this as limit of negative 1, 1 minus 1 over x. So this becomes limit. Instead of taking the limit, let's combine the x, so that will give us negative 1 over x, x minus 1, right? As x approaches infinity, and then the x would go up, so negative x over x minus 1, right? So again, if we take the limit of this, it would give us infinity over infinity. So substituting infinity would give us, again, an indeterminate form. So we need to use L'Hopital's rule. So taking the derivative of negative x, that's negative 1. So limit, let's write it again here. Negative x over x minus 1. So since we need the L'Hopital's rule, so this will become negative 1 over 1. So essentially, our y is actually, so this value, remember, this is equivalent to y equals 1. So let's substitute. So our y is equal to 1. So exp, so of 1 is actually where do we get, did I miss something here? So exp is exp. Okay, sorry. So y equals 1. So exp ln of exp 1 of y would be ln of exp of infinity, right? Oh, negative 1. So, sorry. I missed the negative here. So it should be negative 1. So from our original substitution of exp, it should be negative 1. So we don't need to do this. So this is actually e is equal to e to the negative 1 or 1 over e. So this is our final answer. For limit of 1 minus 1 over x raised to the x as x approaches infinity. So sorry, I didn't see here. So this is our limit. This is equivalent to your y, which we initially substituted earlier in the equation here. So we got rid of exp. So we took y for this entire limit here. And we tried to solve this part here, and we got an indeterminate form. So we manipulate our function to be able to get an answer which is not an indeterminate form, but we again got 0 over 0. So if it's 0 over 0, we can do Lopitals. And we arrive from here, and we got again an infinity over infinity. So we did another L'Hopital's rule, and we arrived to negative 1 over 1. So this is our y. And then we substituted back to our original equation. So exp negative 1 is actually e to the negative 1. And that is 1 over e. Okay. All right. So that is for problem number 6. Okay, let's do let's do number 7. So what is problem number 7? Problem number 7 is from Ati. He's from college and he lives in the Bay Area. So just make it a little bit bigger. So again, this is a calculus problem. And it says here, to evaluate the integral of 5x to the 4 dx over the square root of 9 plus x to the 10, which of the following, excuse me, which of the following formulas can be used? So, so there are actually 3 integration. These are taken from the integration table, and we will just actually select which ones to use from 1, 2, or 3. So is it either 1, 2, or 3? And let's try actually, so let's start with number 1. So let's try when a squared is equal to 9. So a is 3, right? So because of this value here in a radical sign, and then let u squared, so let a squared equals to 9, and then let u squared equals to x to the 10th. So our u would be equal to x to the 5th, right? And so if we take du from this, du, take the derivative of x to the 5th, so 5x to the 4th, right? So which is exactly what we got here is the numerator of our integrand. So I think for number 1, we can actually use this formula. Okay, so since we already defined u, and we already defined a, and we already defined du, so this means this is equivalent to, so let's try the original integrand. So integral of 5x to the 4th dx. So this is actually with dx, sorry. And then divided by 9 plus x to the 10th. So 5x to the 4th dx, actually your du. And then your 9 would be your a squared, and x to the 10 would be your u squared. So we have the exact formula for number 1. So the integral of this would be, it says there, ln of u, which is x to the 5th, and then plus square root of u squared. So our u squared is x to the 10th plus a squared, which is 9. And okay, and that's it. And then plus c, since this is indefinite integral. So our answer is this. So ln of x to the 5th plus square root of x to the 10th plus 9 plus c. Okay. All right. So I think we already answered it. Was the function u. So this is x to the 5th. du would be 5x to the 4th dx. And yeah, right? And this is our answer for the integral. Okay, let's go to number 8. Okay, question number 8. So actually, this is from Lena, and she sent us 2 questions. And this is also another calculus problem. She's in college and she lives in Manila, Philippines. Okay, she didn't put what school. Okay, let's read this problem first. Let me just move it here. Okay, so the first question is number 12 says, consider the region are bounded by the line y equals 37 minus 7x and the parabola y equals 27 minus x squared. Find the volume of the solid when r is revolved around the y-axis. So the first thing we need to do here is, so we can see, imagine how the graph would look like is, of course, let's graph it. So to make sure, so let's go first to, what's this one? To Desmos. So y equals, so that's problem number 8, right? So y equals 37 minus 7x. So 37 minus 7x. And then the second graph is the parabola. So y equals 27 minus x squared. Okay. Oops. Forgot the 7 here. All right. So if we go here in the graph, so the blue portion is actually your parabola and the red line is the red portion is your red line. So if we take the intersection of these two, so we have at 223 and what's the other one? 5 and 52. Okay, let's go back to our whiteboard then. Okay, let's try to draw it. So let's put it here. So given our line is 37 minus 7x and the parabola is 27 minus x squared. So try to draw it. So it's downward parabola. We have here a 27, and if we take the intersection of the line and this parabola, we have this. Okay, let's try to redo it with a different color. So this would be like that. Okay, and we found out that this is 223 intersection, and the other one is at 52. So what is the question again? Where do we need to? So find the volumes of the solid when R is revolved around the y-axis. So we need to revolve this intersection of two curves in the y-axis. So rotate here or revolve here in the y-axis. So we need to rotate here or revolve here. Okay, so we already graphed it, and then we know the intersection. And what else we need to do? So there are two things here. We need to decide to take a horizontal slice or a vertical slice. So if we take a vertical slice, we will do cylindrical shells, the method of cylindrical shells, right? So if we take the horizontal slice, so horizontal slice is like this, we would be using the method of washer, or the washer method, or the ring method in solving the volume of solid of revolution. So let's use the washer first. Okay, so let's try to use the, we call this the horizontal slice. So this would become dy, right? And our r would be from here. So r, sorry. So r from here. Let's make it the blue one here. So the blue part would be here, the r, the bigger r, and the distance from the parabola to the axis of revolution would be the bigger r. Let me just raise this. And then for the red part, which is the line, that would be your smaller r, or the radius from here up to here. So if we actually take the you call this top view of this curve, this would be looking like this. So the one outside, oops, let's try to use a different color. So the parabola would have the blue ring, and then the inner ring, which is the line, would have the red ring here. And the middle part would be your y-axis, where it revolved, where we revolve the two curves. Okay, so this is the top view of our curve. So and this is our thickness of our slice here. So from the middle up to the end, that's your bigger r, right? And the smaller r would be the one inside the smaller circle, and this would be our thickness, which is dy. Okay, let's try to form our equation. So since this is our circle, so the volume would be, oops, so V is equal to the integral of pi r squared minus r squared dy, right? So because the area of this, or the is pi r squared minus r squared dy. I mean the area of the circle, not the volume here. Okay, so what is actually our r squared? So r squared is the distance from the parabola up to the axis of revolution. So this is actually a x value. So let's try, what is the x value of our parabola? And it's in terms of y, right? So how do we move it here? So x, so this could be written as x squared equals 27 minus y, and then x would be square root of 27 minus y, right? So we have our x for the big R. So this is our big R. So let's write it here. Square root of 27 minus y. And then how about the small r? So again, if we go up, this is equivalent to so 7x equals 37 minus y, or x is actually 37 minus y all over 7, right? So that's our small r here. So okay, let's try to substitute it here. So small r is 37, what's that again? 37 minus y over 7. So if we take the square of this two, okay, and get the limit. So what limit should we use? Because we're using y, right, as our slice. So from our intersection, we need to get 2. This one here, and what's the other limit? 23. So 2 to 23. Oops. Okay, substitute again all the values. It can take out actually pi. So, and then r squared should be 27 minus y square root. But then there's a square, and then minus r squared. So 37 minus y over 7 squared. And then we have our dy. So let's take the bracket dy. Okay, let's simplify. So this is pi, and this is the limit from 2 to 23. And then since this is a radical sign, it would be gone, right? 27 minus y minus 37 minus y squared over 49, right? And then dy. Okay, we can expand the denominator of the second term. So, and let's actually distribute first 49. So let's have pi here outside, and then 2 to 23. So what is 49 times? So 49 times 27 is 1,323. And then minus 49y. So again, all over 49, because we put 49 as our all over all denominator. And then let's expand what is inside. So 37 squared would be 1369. And then minus 37 times 2y, so minus 74y. And then plus y squared, right? Okay, so and then our dy, of course. So, and then let's combine like terms. So see, earlier we're doing in algebra combining like terms, but it's in still on you know, elementary basis of combining the variable x and x squared. It is still called this usable when we're doing calculus, right? In combining like terms to make our life easier. So phi, let's take out 49 and then simplify our numerator, right? So 11369. So we can combine this two, right? So 1323 minus 1369, that is negative 46. And then we can combine 74 and 49. So this two here. So this becomes positive, right? So 74 minus 49. So that is plus 25y. And then the y squared, because of this, becomes negative. So it's now the simplified form of our integrand. Okay, so we can take the integral of this. It's easy. It's a power rule. So phi over 49. So negative 46 y, right? And then this one is 25y squared over 2 minus y cubed over 3. And that is from 2 to 23. So let's substitute the limits, the upper and the lower limit. So pi over 49. So negative 46 times 23 plus 25 times 23 squared over 2 minus 23 cubed over 3. And then this becomes plus 46 times 2, right? And then minus 25 times 2 squared over 2, and then 2 plus 2 cubed over 3, right? Okay, let's actually, so negative 46 times 23, that is, negative 46 times 23, that is negative 1058 plus, so 23 squared times 25 divided by 2. So 25 times 23 squared. So 13,225 over 2. And then minus 23 cubed. 12,167 over 3. And then 46 times 2, that is 92. What else? So minus 50. Because this cancels out, right? So, and then 8 plus 8 over 3. Okay, let's try to simplify this. So that we have a fraction and we have whole numbers here. So let's try phi over 49. So let's try decimals. So negative 1058 negative 1058 plus 13,225 over 2 plus 13,225 divided by 2. Oops. 13,225. Okay, divided by 2. And then next is minus 12,167 divided by 3. So minus 12,167. 12,167 divide by 3. And then what else? 12,167 divided by 3 plus 92 minus 50. So plus 92 minus 50. Minus 50. What else we need to add? And 8 over 3. Okay, last one. Plus 8 over 3. So do we get? So that is 3087 over 2. So this is 3087 over 2. Let's see if this is divisible by 49. 3087 divided by 49 is 63. So this is actually 63 pi over 2 is our answer. All right. Good. So that's a long process. So let's recall what have we done. What steps did we take here? So first, we graph the equation so we can see which which graph is on the right side and which one is on the left, or which one is on the top or the bottom. And then we solve. Actually, we don't manually solve the intersection, but we should know the intersection. So because this will be our basis of our limit for the integral equation. And then what's the next step we did? So we did decide the slice. So we have to pick a horizontal. So if it's a horizontal slice, that is your dy, or a vertical slice, which is your dx. So we actually choose dy, and since our axis of revolution, or where do we need to revolve our graph, is in the y-axis, so we use the method of cylindrical shells. Oh, sorry, what do we use washer, right? So we use the horizontal, sorry. So washer, method of, so ring or washer. So ring or washer method. And then for the vertical, if we try to get the vertical slice, so this would be your method of cylindrical shells. So once we decided what's the next step? Once we decided the slice, now we can form our integrand, right? And then next step is to solve the integrand equation, and that's it. So form. So I mean, this is forming the integrand, and then solve it. So okay, so right. So what's the next question? Let's go back. Okay, it's another volume problem, but let's try to solve it. So again, this question is from Lina, right? Yes. Question number 8 is from Lina, and she's from Manila, and she's already in college. So the second question is, so the region bounded by f of x is negative 4 sine x, x equals phi and x equals 2 pi and y equals 0 is rotated about the y-axis. Find the volume of the solid of revolution. So, okay, let's again let's write it here. So our f of x given is negative 4 sine x, which is a trigonometric function, and then x equals pi, and the other one is x 2 pi, right? And then we have y equals 0. All right. And then where do we need to rotate? So rotation at the y-axis. And of course, we need to find the volume. Okay, so let's try to draw our graph. So if I have this axis, so this is a sine, so it is actually 0 at point 0. So, and this will be it. So at pi is also again a 0. So this would be your pi, which is also given as a boundary. So let's draw the line here. So x equals pi, and then the other x is 2 pi. So which is actually at this boundary here. So 1 period of a sine wave. So x equals 2 pi. So since you already, okay, where is the axis of revolution? So again, it's in the y-axis. So this is your y-axis here. So revolved in this axis. So if we take a slice, so let's decide what kind of slice we take. So initially we use the washer method. Now let's try to use the method of cylindrical shell. So if we'll take a slice which is vertical, so this becomes your dx, right? Our slice is our dx. And our distance from the axis of revolution would be x, right? Okay, so how do we form our equation? So since we already know our intersection, which is this point here and this point here, right? So this is pi 0, sorry. This is pi 0 and this is 2 pi 0 at this other end. So when we revolve this dx or our slice to y-axis, it will actually form a cylinder. So if we take the top view again of our cylinder, so let me change my ink to, oops. So this is your y, and the thickness would be your dx. So this is, so the thickness from here up to here is actually your dx. And the height would be your y, right? This is your y. Of course, this is, right? So our height is actually your y, which is equal to negative 4 sine x. And since the lower part is actually the x-axis, so which is here, okay, which is exactly this point here. So we need to find the cylindrical shell, which is equal to, our area of a cylindrical shell is equal to 2 phi RH. So R is actually your X, this distance here, right? So this is your H. Let me change the color of my pen. So this is your R, oops, which is equal to X, and the distance or the height is actually your the f of x, or the negative 4 sine x, right? So let's form our integrand. So we already know the formula for our area, and we know that dx is our thickness. So v will now be equal to 2 pi. The r would be your x, so x, and then h would be your f of x, which is negative 4 sine of x. Oops. Negative 4 sine of x dx, right? So what would be our limit? So since it's in terms of x, so that's actually our two lines bound from pi to 2 pi, okay? So this is pi to 2 pi. Okay, so we can actually use table of integrals in solving this, or we can use the integration by parts. So let's try to use integration by parts. But let's first rearrange the integrand. So let's take out 2 pi from the integral equation. So pi, 2 pi, negative, and also 4. Okay, so negative 4 times 2 is negative 8. So negative 8 pi here, and sine x dx, right? So by using integration by parts, let u is equal to x. So du is dx. And then dv would be equal to the integral of sine x dx, right? So this part here. So v is negative cosine of x. When you get the integral of sine x dx, that would be negative cosine x. So what is the formula for uv minus integral of v du? So so uv is x times negative cosine of x minus integral of v, negative cosine x, and the du is dx. Right, so we have this, and then the negative 8 pi outside. Okay. So we can combine this, so negative x cosine of x, and then plus integral of cosine of x dx from pi to 2 pi, or from pi to 2 pi here. So what's the integral of cosine x? That is sine x, right? So negative 8 pi negative x cosine of x plus sine of x. And our limit is from pi to 2 pi. Right? So let me just take. So, and then we substitute our limits. So 2 pi and pi. So negative 8 pi, negative 2 pi cosine of 2 pi plus sine of 2 pi. And then minus minus, so that's plus pi cosine of pi minus sine of pi, right? So negative 8 pi outside. So cosine of 2 pi is actually 1. So we have negative 2 pi times 1, right? And then sine of 2 pi is actually 0, so plus 0. And then cosine of phi is negative 1, so pi times negative 1. And sine phi is actually 0, right? So minus 0. So we can combine this two. So negative 2 pi minus pi is negative 3 pi. So negative pi times negative 3 pi would give us, oops, what is this? So 8 times 3 is 24, positive 24 pi squared is our volume. All right, that's it. What time is it? So let's see the last problem. Okay. So, okay, for number 8, the second question from Lina, the answer is V equals 24 pi squared. Okay, last question. So this is actually problem number 10. This is from Abby, and she's a college student, and she's also from Cebu, Philippines. So let's try to solve this. Okay, so find the volume formed by rotating about the y-axis the region enclosed by x equals 9y and y cubed equals x and y is greater than 0. Okay, so let's graph our equation. So we have x equals 9y and then y cubed equals x and then y greater than equal to 0. So it only means this is in quadrant 1 and 2, right? When y is greater than or equal to 0. So if we draw it, so let's try to use Desmos. How does it look like? So x equals 9y. X equals 9y. And then the second curve is y cubed is equal to x. Okay, where is it? Okay, this is our graph. So the blue portion is our line, x equals 9y, and then the cubic curve, which is the black one, is y cubed to the x. So we're only concerned with quadrant 1 and 2. So we don't care about the one below the x-axis. So it's only above x-axis, which is y equals greater than 0. So let's try to draw on bit paper. So this would look like, so this is my curve. And then the line here. Okay, let's use another color. So let's use the line. Okay, so this is my line. So this is your x equals 9y. And then the yellow or orange one is y cubed equals x. So let's decide. Okay, let's see what are our... So one intersection is at 0, 0, and the other one is at 27, 3. So this is 0, 0 here. And this one here is actually 27, comma 3. Okay, let's decide. Let's try to use again the cylindrical shell. So let's take the slide. So hold on. Where do we need to revolve it? So rotating again at the y-axis. So revolve at the y-axis. So let's take the slice here. So this is dx, right? So if we rotate dx to y, we will form again another cylinder. So we already know that the area of a cylinder is 2 pi r h, right? And our r here would be your x. So let's change this to green. So this is your x distance from the axis of revolution. And then your h would be the height of this slice. And actually h would be y on top, which is the parabola, the cubic, minus y at the bottom, which is the line. So y on top. So this should be in terms of x. So let's try to solve this first in terms of x. So y equals x to the 1/3, right? And this one here should be y equals x over 9. So y x to the 1/3 is the one on top. So x to the 1/3 and minus yb, which is x over 9. Right? So this is, if we try to draw that line here, the slice here. So this is our slice. So if this is our curve and this is the line, so this is your yt and this is your y. So yt and yb. So basically that's it. No need to draw here. So let's form our integral equation, which is our volume. So v equals integral of 2 pi x, right? Which is our r, or the radius, or the distance from the slice to the axis of revolution, and our h, which is we already know as x to the 1/3 minus x over 9, and then our slice is dx, right? So we can actually take, okay. So what is our limit? So our limit is from 0 up to 27, right? So this one here. So 27, 0 to 27. And what's the next step? So let's take out 2 pi from the integral equation, or from the integral. And then let's distribute the x to the one inside the parentheses. So x times x to the 1/3. So x 2 to the 2 or plus 1/3. So that would be 3 over 3. Sorry, it's x 3 over 3. So this is 4/3, right? And this will be x squared over 9 dx from 0 to 27. Okay, so we're ready to integrate. So 2 pi. So 3 over 3. So x to the 7/3 over 7/3 minus x/3 over 9 times 3 from 0 to 27. Okay, so 2 pi. So this is 3x to the 7/3 over 7 minus x to the 3rd over 27. 0 to 27. So let's substitute our limit. So this is 0. So 3/27 to the 7/3 over 7 minus 27 to the 3rd over 27. And then if we substitute 0, both are 0. So plus 0 minus 0. So again, 2 pi here. And then what is 27 to the 7/3 times 3? So I got 6561 over 7 minus 729. So the 6561 over 7 minus 729 would give us what? So 6561 divide by 7 minus 729. So if we take the fraction part, that's 1458. 1458 times 2 pi over 7. So 1458 times 2 is 2916 pi over 7. So this is our answer. All right. I think we're done. So no more. Yeah. Okay. So no more problem to solve. Okay. So I hope you learned something today. So thank you for sending in your questions. Thank you to Kendra from New York, Stephanie from San Francisco, Fernando from San Mateo, if you're watching, Kyla from San Jose, Ami from San Francisco, William from Mindoro, Philippines, Ati from the Bay Area, and then Lina from Manila, and Abby from Cebu. So I hope I help you with your homework or with this problem that you sent in. So, okay, so next time, all problems that was sent from today, which is Thursday here, up to the next what is that? So next Thursday up to Sunday. So that will be Friday, Monday in Manila. We will be solving it next week on Tuesday. Again with Math Agility Live. That would be on March 23 PST. And it's actually Wednesday in Manila, which is March 24 from 6 p.m. to 8 p.m. PST. But it's 9 a.m. to 11 a.m. Manila time. So again, see you next week and God bless everyone and stay safe.